cloud. All right, we are recording. So let's take a look at numbers 10 and 11. This is a common question, so I'm glad you asked this one, Brittany. It's all about when we're doing these confidence intervals. Oh, this is actually, so this is 8.2. So it's all about like, what do we use for our sample size? What are we dividing? What divided by what? So let's see here. According to national data, the completion rates at two-year institutions is approximately 0.224. In the college scorecard data, we can see that ECC's completion rate is about 0.3. So in that particular year, I think this is a couple years outdated, we had about a 30% completion rate. And again, completion is defined as you complete your program within actually 3 years. So here's the key. If this completion rate was based on a sample of 908 incoming recent high school graduates. So the answer to your question, Brittany, is that that 0.3 is not 30% of all the students in that database. If you open up the database, to your point, there's whatever, 8,000 students. That's the number of students enrolled that year. This completion rate is only based on a sample of just the new, what is it? It's incoming recent high school graduates. So if you look in 2020, they'll look at how many students graduated from high school in 2017 and then started in 2017. Did they complete by spring 2020, right? 17 to 18, 18 to 19, 19 to 20, yeah. So that's what that's not all of them. So if we want to answer this one, we consider the 908 students to be a sample. What will, there's a verb missing there, what will be the sample proportion of those who completed? Will that be approximately normally distributed? Why or why not? So the key here is that we have a sample size of 908. We have a population proportion of 0.224. So how do we check if the sample proportions will be normally distributed? Does anyone remember? You could type that. There's a couple things we have to check to see if the sample proportions will be normally distributed. So does anyone remember what you need to check there? I can look and navigate to the online lesson for this, if that would be helpful. Not seeing any raised hands. This is not a good sign. You should know this or have this written down in your notes. In order for the sample proportion to be approximately normally distributed, 8.2, there's the sample proportion. Here it is. Okay, so here's the key for a simple random sample of size n such that n is less than 5% of the population. The shape of the sampling distribution will be approximately normal, provided n times p times 1 minus p is at least 10. So we need to check those two conditions. Yep, you got it right, Daniel. Is our n less than 5% of all the population? And is n times p times 1 minus p at least 10? So let's see here. I'm going to move this to the other side. I'm just going to open up like a StatCrunch or a, I don't know, maybe a Desmos calculator window. It's a nice scientific calculator. So first of all, our sample size is 900, and we're looking at that being a sample of all community college students. If we consider to be the 908 students to be a sample of all incoming recent high school graduates at community colleges across the country. Well, that 908 is definitely less than 5% of all. And that's usually going to be the case. All right, so then we need to check n times p times 1 minus p is at least 10. So n, our sample size is 908. What is our p? Be careful here. What is our p? There's two choices. Do you know which one it is? You can type it in the chat or just unmute yourself. This class is always so quiet. So what is the p here? We have two options. It's either 0.3 or 0.224. You got to know your symbols. We should, ooh, hold on. I can do polls. Let me see if I can do a poll. Okay. Enter a title for this. P. Type your question here. Which is P? 224 or 0.3? Okay. I tried this earlier. Let's see. Save. Okay. Launch polling. Okay. Polling is now in progress. So which one do you think is P? 0.224 or 0.3? This is kind of cool. This is my first poll that I've ever done. I tried one this morning and it didn't work. Can you see the results, or am I the only one that sees the results? We have 5 people so far voted. Let's give it another 30 seconds. We don't want to sit here and wait forever. So far, the majority is doing pretty good. Six people. This is kind of cool. I like this. A little more interactive instead of just sitting there and watching. Honestly, if you're just going to sit and watch, I should just record videos and post them, and then why have class? So I want you following along if you can. All right, that's close enough. End polling, and then does it like, okay, share results. Share results. Cool, see? All right. That's somebody trying to prank us there. That's why I had to like do the waiting room. Okay, so did you see the poll, or did it? I had it up for a second, and then we had like a new visitor, an unwanted visitor, come in. The people who answered 0.224 that is correct. The key here is you have, for the 2 proportions, one of them is the population proportion and one of them is the sample proportion. And so the 0.224 is the P, that's the population proportion, that's P. If it has the little hat symbol over it, that's the sample proportion, that's our 0.3. So the answer to question A is we have to see if N times P, see if you have the chat window up, this is what Daniel was typing there, N times P times 1 minus P, is that at least 10? Yeah, it's 160. So yes, P hat should be approximately normally distributed. The sample proportions should be approximately normally distributed. Now the question, what is the distribution of the sample proportion who complete for samples of size 908? So we go to the lesson again, and you will see here's the mean. You would expect, on average, now we are getting, this is interesting. So this, I'm glad I'm doing the waiting room, because now we have another person waiting who definitely does not want to be in, should not be in here. So that's really interesting. I don't know how they find these meetings. So you will see here that we would expect on average, the mean sample proportion should be the same as the population proportion. The standard deviation is a little funky. You're going to want to write this down, have this handy. Square root of P times 1 minus P over N. So what we will do then is just calculate that. The square root of P, nope, I need to put it in 0.224 times 1 minus 0.224 divided by N, which was 908. So this is our, this is the standard deviation of those sample proportions. So one tip that I have for you here is to not round this, because we're not giving this answer as part of the question. This is going to be part of a calculation. So for part C, we're going to want this number, and so we're going to want to not round it. In fact, you can type it into StatCrunch without rounding at all. I'll show you how to do that. Okay, so I think we're ready then for part C. Would a sample proportion of 0.3 be considered unusual? Okay, another question for you. We've asked this before. How do you determine if something is unusual? How do you determine if something is unusual? And you can unmute yourself or type it in the chat, whatever you prefer. Right, Justin, you nailed it. It has, whatever that event is, it has a less than 5% probability of occurring. So we need a probability. Well, what kind of probability are we going to use? We have this probability calculators. What probability are we going to use? How are we going to determine the probability of getting 0.3% and seeing if that's unusual? Should be, yes, Brittany's right, normal probability, normal probability. So we'll do normal. And we already found the mean and standard deviation. That was in part B. So the mean should be the same as the population mean, 0.224. It's really population proportion, right? So it should be the same as the population. The standard deviation is that thing I calculated. So you can copy and paste that. That's fine. Or you can even type in square root of 0.224 times 1 minus 0.224 over 908. So you can even type it in like that. And if we want to find unusual, here's one thing that's a little unclear, is you don't know which direction to go. So what you do is you say, well, I'm going to find the probability of that or more, like out. So 0.3 is above. So if I do less than, oh, it didn't take the square root. Oh, it used to. Oh, maybe it doesn't. Okay, so maybe I typed it in wrong, but I'm just going to copy and paste my Desmos output here. Copy. Try that in here, paste, compute. So 0.3 being less than that, well, 0.3 is actually above, so I should probably find the probability of being above that. So when you find whether something is unusual, you have the mean in the middle, and wherever your observation is, you find the probability of being there or out, whatever side it is. So that's the unusual thing. Okay, so is it unusual to get a sample proportion of 0.3 if the real proportion is 0.224? What do you think? Wait. We need a new poll. Stop sharing results. Oh, I need to like, oh, I can't do, I need like a new question. Well, I can edit the question. All right, that's not worth the time. So what do you think? Is that an unusual event? We got a probability, where to go? Probability of point, yeah, pretty obvious here, right? This is gonna, oh, I can't even read how small that is. There's 2,000ths, millionths, like 200 millionths. So 2 out of 100 million times this will happen. So definitely very unusual, yes. If this question were to be on an exam, you don't want to just answer yes or no, right? You're not going to get credit. You can just guess. So no credit for that. What you want to do is answer yes and then say why. Yes, because the probability of it occurring is 0.000000002. And then one thing you can even do is take your StatCrunch output and copy it. You can just right click, copy this image, and then say you have a Microsoft Word document or you're using Google Docs at home, whatever, it's fine. And you can just paste that in there, and that's your work, right? That's your work. That's how you show how you found that probability. So no sense, like when you're submitting things here, I'm not going to be printing anything, so you can use as much space as you want. So feel free to paste that in as your work. So that's number 10, Brittany, and I know you were wondering about number 11 as well. Let's see if it's the same issue here. This one, the proportion of students who receive Pell Grants is also recorded in the database, ECC values. So 35% of ECC students get Pell Grants. Those are income-based, so you have to be below a certain income threshold to qualify for those. The national value is 0.396. ECC's enrollment was 8,354. So here we can see the 8,354 is the sample size. So now the N is 8,354, and it's really the same question as number 10. You do the same analysis, same steps. Notice it's the same A, B, and C. So those should be exactly the same. So how are we doing on those, Brittany? Does that clarify your questions for those? Okay. Anybody else have questions? And you know, these can be like you know, we did the talk about how the class is going to run, but, you know, if you've had additional questions that come up, let me know about those too. Anybody else have any additional questions from the practice or anything like that? Okay, I am not seeing any. So I think what I would like to do next is let's do this exercise for the confidence interval. So we've talked about normal probability, the distribution of sample means. We did that on Monday. And then today we did the distribution of sample proportions. So we did some examples there. So let's talk about confidence intervals. This kind of reminds me, actually, oh, I don't know if I can find that link. Let me see here. Hold on. Shoot. Reminds me of something related to what's going on right now with the virus. And there was an interesting confidence interval thing that actually just came up. I have way too much on the screen. The Zoom is kind of cool, but it like covers everything up too, so then I can't see behind it. Let's see here. Yeah, that's the one I want. So there was this model, and I think this was just on the federal government report. There was like a news conference, they talked about it. And they were talking about, you know, hospital beds needed and why we want to stay home. And these people who are trying to break in, like they don't even have, like they're making it obvious. Like the names are like, oh, that's really bad. So they have this like predicted number of beds that are going to be needed, predicted number of ICU beds, and you see these purple bands on there. That means like there's a lot of uncertainty. So they think it's going to be here, but then there's like this interval. And that's really what we're doing baby steps into that. These are super sophisticated models, but it's all about, you see at the end, I don't know if you can see that. I can't like hover my mouse over it, but it has the like all beds needed, projected, it has a number, but then it has a lower and upper limit. That's a confidence interval. They're saying, well, we think it could be anywhere between this and this. And that's what we're doing in chapter 9 is we're going to find confidence intervals. Not like this. We're not that fancy yet. In fact, I don't even know how to do this. But we're going to find some confidence intervals. So what we're going to be doing here is we're going to be saying, like, we take a sample of students. Like Justin's project was going to be about surveying students in this high school community college program. And maybe he asked how many felt it was helpful. And so he got 70% of his sample said it was helpful. But that's just one sample. How do we know that all of them will feel that way? So we might say, well, we're confident it's between here and here. So the question is, how do we get the here and here? And that's what confidence intervals are. So let's do this exercise. Let's go, you can follow along. That would be ideal. I'm actually not going to type this in this time. So if you want to follow along and have yours up and kind of be entering this along, that would probably be best. So let's do number 12 from the practice. We're going to open up applets, confidence intervals for a proportion. And then we're going to do 0.224. That was the success percent, if you recall. And then we're going to do sample sizes of 100. So in StatCrunch, I already forgot where that was. So applets, confidence intervals, applets, confidence intervals for a proportion. And our proportion, our population is about 0.224. And we want to do a sample size of 100 and a confidence level of 0.95. We'll compute. So what you should get is, in fact, 100 little lines. Yours will not look just like mine because you did different samples. So what this is pretending, each one of the dots in the middle is a random sample was taken and they got a sample mean. So this one I'm highlighting here. has a sample proportion of 0.21, and there's this lower and upper limit. Now, it's not talking about where that lower and upper limit came from yet. We don't know that. We will talk about that. But it's giving you this lower and upper limit. And you'll notice some of them are red. Do you know why they are red? I have, looks like 3 red ones on mine. Does anyone know why I have 3 red ones here on mine? Yours, you might have 5 or 7 or 2. The ranges don't reach. Yeah, it's not the mean, it's the proportion this time, but you're right, it's the same idea, right? So what we're saying is like this red one here, if I can hover over this one. Let's say we take a sample, we get a sample proportion of 0.34. And so they say, well, we think it's between 0.247 and 0.433. And they do that. And you're like, well, you're wrong. It was actually 0.224. Now the problem is, this is what's a little abstract for students, and it's normal for this to be a little confusing, is when you're the researcher, you don't know if you're a green bar or you're a red bar, because you don't actually know the 0.224. You're collecting new data, like Justin's survey. I keep referencing him because he's the only face up. I'm sorry, Justin. Justin's survey about students and their perception of the program, the AVID program. He doesn't have the data from every student. He only has sample data. So he doesn't know whether he has the real true proportion or not. When you see polls about elections, they didn't ask every single person who's going to vote. They just did a sample. So they have this margin of error, and you don't know if you're a green or a red bar. But with some statistical background, and that's kind of what that's what this course is about, and what StatCrunch does for you, you can give a confidence level. Now that confidence level doesn't say this interval has a probability of including the real one, because either it does or it doesn't. What it says is if I did this process 100 times, how many, like if you did this more and more and more, and you did, if we averaged, if everybody's doing it right now, and we averaged how many contained the real value, do you know about how many out of 100 should contain the real value? Do you know what that answer is? You know, I had 97. Can you type in how many of yours contained the real value? I don't know how many other people are able to do this with me. Maybe nobody. So Daniel had 94, that makes sense. 93 from Elliot, 95 from Brittany. Mine was 97, okay? So that all makes sense to me. Do you know what we would expect? How many we would expect? Do you know what that answer is? Yeah, Daniel's right. If we did like 1 million of them, we should get 950,000 of them should intersect this. So what this is saying is when you do one confidence interval, you don't know whether you hit it or not. But if you repeat that process over and over and over, and you get a new sample, brand new sample, and then you find a confidence interval for that sample, and then another brand new sample, get a confidence interval for that sample, and another brand new sample, get a confidence interval for that sample. If you do that often and you repeat that over and over and over, if you do a 95% confidence level, that means 95% of your intervals should contain the real true value which you're trying to guess. Now our problem is we don't know if ours is correct or not, so that's why we have this confidence level. So let's go back to the practice to see here. What does each line with a dot represent? So it represents a confidence interval. Why are some red? That's what Daniel's point they missed. Your answers are all going to be different here for letter I here, number 1. Because you're, like I had 97 out of 100. But you might have a different one. So just write down your number there. I'm not going to ask, like in the quiz this Friday, I'm not going to ask that because everybody's going to be different. So that's definitely not something I'm going to ask. What proportion would we expect? And that's where Daniel was saying we'd expect 95%, right? That's how many we'd expect. And why are they not the same? That's where I'm alluding to. We only did 100 samples. there are lots of samples there. We could redo this again and again and again. In fact, I think if I go into StatCrunch and go sample size, let's do 100, let's do 1,000 intervals, and 1,000 more, and 1,000 more, and 1,000 more, and 1,000 more, and do more and more and more intervals. And if I maximize this, oh, my proportion is a little bit under. It's 0.94. So eventually we would expect about 0.95 there. This is actually, yeah, so we would expect about 0.95 there eventually. That's the idea behind what a confidence interval is. Let's see, was that it? Yeah, so let's do an example here to find one particular confidence interval. I think there are several here, so we'll just do one together, and I think that'll be about it. Maybe we should do a different one. Let me see here if I can find a different example so I don't just do all the ones that are in your practice. Let's see here. See if I can find a good one. Figured I should start wearing like actual work clothes now and not like sweatshirts since I'm officially working. So I decided to get out some actual work clothes. Let's see here. I'm still trying to get in my course rhythm here too. Unfortunately, I am not as prepared as I would like to be. So I think what I'm going to do is open up practice exam for this unit and steal a question from there. Let's find a confidence interval. Aha. Oh, nope. That's the mean. Okay, here we go. Let's do number 10. So we actually did this analysis, and I think I used this in the video if I remember correctly. I can't remember right now offhand if I did or not, but we're trying to find a confidence interval for the percent of students who would succeed. In this case, we're looking at the ones who succeed in Math 98 intermediate algebra. And we're looking at those who did well in high school, 3.5 or higher cumulative high school GPA. They had an 82% success rate. But that's just a sample of 100 students. And suppose we might wonder, like, well, how many, like, how confident can we be? What will be our margin of error, our confidence interval, if we looked at all students like that who got a 3.5% or 3.5 or higher cumulative GPA? The question here is asking, by the way, about what should the article report as the margin of error. So we'll get to that. But let's find a confidence interval. If we go into StatCrunch, where did that go? Nope, that is not it. Too many windows open. Oh my gosh. All right, StatCrunch, and we go to stat. We're going to do Z stats. No, not Z stats. Proportion stats. One sample. Now, data or summary. So data you would only use if you had those 100 students in a list, and then each student was either yes, no, yes, 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 no, 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 for whether they succeeded in Math 98. All we have is an overall summary. So we're going to go with summary. So for confidence intervals, stat, proportion stats, one sample with summary. And you'll see here, it says number of successes and number of observations. Now I know I have 100 people, but I don't know how many were successful. So we have to think a little bit about this. And this is actually pretty common. Let's go back to that question. So suppose a random sample of 100 recent high school graduates who earned a 3.5 or higher cumulative high school GPA had a success rate of 82%. So that 82% is our sample proportion. but StatCrunch wants the number of successes. So does anyone have any idea how we could figure out what the actual number of successes was? That's the question. So in our sample, we actually need to know how many students were successful. We need a number there. N times P? Sure. So you take the sample size, and actually would be N times P hat here, because it's the 82% is a sample proportion. So the 82% is a sample proportion. It's not the proportion of all students of this, it's just the proportion of that 100. So it really just is 82 out of 100. But for future reference, if the math isn't that easy, what you can do is you just take your sample size, 100, and multiply by that sample proportion. Now here it's easy to just write 82. You can just write 82, that's fine because it's 100. The 100 is kind of chosen here because it's easy. They won't always be that easy. We want to do a confidence interval. And then what confidence level? If we were to write an article that uses a 95% confidence interval. Okay. So 95% is our answer. So 0.95, and then we'll hit compute. And there's our interval. The key we want to look at here is lower limit, upper limit. So about 74.5% to the 89.5%. Is there a way to show, yeah, plot? Let's do a plot. I like visuals. So here's our interval. It's not a very exciting plot. It just has your 82% in the middle, and it could be as low as 74.5 or as high as, was it 89.5? If we hover over this, does it? Oh, nice. It even gives us our lower and upper limit. So here's why I wanted the visual. If we go to the question, notice it doesn't ask us for the interval. It doesn't say, what's your confidence interval? Oh, well, we think it's between, we're 95% confidence between 74.5% and 89.5%. No, what it asks for is the margin of error. And here's what's confusing for a lot of students. You see this standard error. That is not the margin of error. That's actually, let me do a quick calculation here for you. I'll be back there, Elliot, just a second. Good question. If you do square root of 0.82 times 1 minus 0.82 over n, 0.0384, check that out, 0.0384. That standard error is actually the standard deviation of your p hat. It is not the margin of error. So let me close this again, Elliot, and we'll try it again. So we are under stat, proportion stats, one sample, because we just have one sample, and then with summary. So stat, proportion stats, one sample with summary. And then what we need here is we need a number of successes and a number of observations. We have 100 total observations. We had 100 students. And we knew 82% were successful, 82% of those 100. So Justin's tip was just to take the 100 and multiply by 82%. And again, that's a little excessive here. You're all college students. We could have just put 82 there. But my point is that's a flexible method that you can do that on more complex examples as well. Confidence interval, we're hypothesis test is actually chapter 10. So we'll get to that soon enough after the next test. So we want a confidence interval, and then you have to put in the level. It did say 95%, right? Yeah, 95%. That's the most common that gets published in articles is 95%. Does anyone know why the 95% is the most common? Do you have any guesses about why we usually do 95% confidence intervals? No response. I don't like that you are so quiet. So it's not a coincidence that we used to think that something was unusual if it had a probability of less than 5%. And so we're doing this 95% confidence interval. That's not a coincidence that we use those two. So to finish this question, then I think that'll be it for today, unless there are other additional questions. We need to find the margin of error. So if it's not that standard error, what is it? Well, it's actually, this is why I wanted to look at the visual. It's kind of on the picture. The margin of error is the distance for like your plus or minus. When you read a poll and it says, oh, it's a margin of error of 4%, what they're meaning is, well, 52% approve this, but could be as high as 56 or as low as 48. And there's a 4% margin of error. And so you can actually get that just from StatCrunch, where you just take the upper limit, 89.5, and then subtract the middle value, which was 0.82. So that can be the margin of error. 0.85, what would that be, 13.5? 89, no, 89.5, no, I'm not good with numbers here, 7.5. So 89.5 minus 82, so the margin of error is 75. You could also do the middle 82 minus the lower limit, 74.5, and that's also 7.5. So that gives you your margin of error is just taking the upper value minus the middle, or taking the middle minus the lower value. Either way, it will do it. Okay, I think that is it. So the margin of error, if we were to report that on that example, would be 7.5%. And again, if we're doing this on an exam, the way you would show your work is you would actually just go to StatCrunch and go here to this screen here and just option. I think you can just actually Control-Alt, copy it. And then I have a Word document up here somewhere. Here it is. And if I want to show my work, I would just paste that. Okay, here's my work. And then I would say, okay, the margin of error is, what do we get, 89.5% minus 82%. And that's 7.5%. And that's how you'd show your work for that. All right. I think that is it. I think that's good. That's a good amount of practice. I feel comfortable with that. Did anyone have any additional questions? I don't know, Elliot, I hope that was helpful. I mean, are we good? Do you want me to walk through the commands again? Anything else? All right, awesome. Okay, so here is our first week of new deadlines. I'll post, when I post this video, we'll write those up there. We're gonna do our My Stat Lab homework is gonna be due tonight. I know there was a little bit of an outage the other day, so if that affected you and you weren't able to work until tonight, just let me know, but we're gonna try to do the My Stat Lab homework tonight, and then the practice is, again, you just do all of that, fill that whole worksheet out, have that whole, I mean, not fill it out, you're not, oops, no, that's not what I want. You're not printing anything out and handwriting it, but have a Google Doc or a Word document, have that all answered out ahead of time, and you can email me questions. I don't know if everyone has found, or if anyone has found the Discord chat. There are some questions here. And there's a little chat window for you, and you can pop in there and post a question about the practice document. You want to have that all done, and then when you're ready, you go into the quiz, and there's a Chapter 8 and 9.1 quiz that will have not everything from that practice, but a selection of questions from that practice, and you'll answer those. You should have everything ready to go. You should just be clicking and typing things in, because it should already be done on your practice worksheet, and that's due Friday at 11:59 p.m. And then we'll just repeat. More videos to watch for next week. I won't see you in a format like this until next Monday. Any questions about what's due and what we should be working on? All right, I'm gonna leave the chat up in case anybody else needs to, like if you're typing right now, so I don't wanna cut you off. Otherwise, feel free to log out and end the meeting for yourself and get to work, and I will see you on Monday. All right, stay safe, everybody. I'm gonna leave the chat window up for a little bit in case anybody has some questions, but otherwise I will see you then. Sure, Rachel, let me take a look here. 8A. Okay. All right, so let me open up the central limit theorem from 8.1, because this is a mean. So the stuff we were doing today was 8.2, which is proportions, and 8.1 are means. So I'm going to open up the Chapter 8 online lesson. And buried in 8.1, we will see how the means should be distributed. There's the central limit theorem. And here we go, the sampling distribution of X bar. And this is something you should like write down, have this handy. It's kind of a weird formula, but what this is saying here, these symbols here, this mu, and then there's the subscript is X bar. What that means is that's the mean of all the sample means should be the same as the population. So whatever the population mean is, you would expect to have that same sample mean. And then the standard deviation of the sample means, they get smaller and smaller and smaller as n gets larger. So that's sigma over square root of n. So for 8, we want to find the distribution of the sample mean of Hispanic percent. So what we're going to do is we have to open our data from my data. And I only have a few minutes here. I think we should be okay. There's Illinois school data. Okay. We need to get that population mean and population standard deviation first. Hey, since it's just the two of us, I'm going to unmute you. That way you can tell me you're following along. Oh, it won't let me unmute you. Maybe you don't have any audio. I don't know. It's all right. So let's see here. We want to do summary stats columns, and we want to do Hispanic percent, and we want the mean and standard deviation of that. So this 19.5 is our mu, that's our population mean, and then 25.5 is our population standard deviation. From the central limit theorem says, oh, I had you there for a second. The mean of the sample means should be the same 19.5, and the standard deviation of the sample means should be 25.5 divided by square root of n. So let me get my Word document up that I was kind of pretending to type in. So if I were doing this as a student for 8A, here's what I would do. I would say the mean is the same as the population mean, so 19.5. And then the standard deviation should be the standard deviation of the population divided by square root of n. So that was 25.5 divided by square root of 26, right? Find the distribution of the sample mean for samples of size 26. So that would be over square root of 26. And use my calculator. .5 divided by the square root of 26. So about 5.001. I like to not round these because that's not the answer you're looking for. It's really part of the rest of the problem. And so I like to not round at that point. So that's how you get the mean and standard deviation of sample means for samples of size 26 for that one. Good. All right, anything else? All right, email me or post in that discussion thread if you have any additional questions. Happy to answer all week here. We're only meeting twice because I'm assuming I'm going to have more kind of emails and stuff to answer, so don't feel bad emailing me anything else. All right, we'll stop that and end the meeting. All right, take care.